So here we will discuss how we can solve a numerical integration using Simpson's one-third rule. So let's see what Simpson one-third rule is. In Simpson's one-third rule, we assume that the integrand y is equal to fx is such that it can be approximated by a second degree polynomial over any interval of length twice h. Here we approximate fx by a function phi x, where phi x is a second degree polynomial from Newton's forward interpolation. So what is the form of the phi x? Then phi x must be y naught plus u delta y naught plus u into u minus 1 by 2 delta square y naught, where u is x minus x naught by h. So after applying this phi in our integrand fx, our formula becomes this. So integral a to b fx dx is equal to h by 3 y naught plus yn plus twice into y2 plus y4 plus yn minus 2. This is the all even terms, and plus 4 into y1 plus y3 plus yn minus 1, and this is the all odd terms. So what is the formula of the Simpson's one-third rule? This is h by 3 into first term of the y value, last of the y values, and twice into all the even values between first and the last, and 4 into all the odd values between first and the last. Okay, so let's see what is the algorithm to solve a numerical integration with this formula. So the first step is divide the interval into n by 2 subintervals of equal length twice each. Here n must be an even number. So a is equal to x0, x1, x2, x3 xn, where a and b are the limits of the interval. Here h is equal to b minus a by n is the width of the subinterval. Then x1 is x0 plus h, x2 is x0 plus twice n, so on, xn is x0 plus nh is equal to b. Now the second step is to evaluate the yi's for each xi from the y is equal to fx, where fx is our integrand. Now we have found y0, y1, y2 and so on yn. Then put yi's in the formula which we have derived earlier, that is this formula. We have to put y0 here, yn here, y2 here, y4 here, yn minus 2 here, and so on and so forth. So this is the algorithm for solving a numerical integration using Simpson one-third rule. But what is the algorithm for programming? So let's see. So first of all, we have to define the function fx. Then after that, we have to initialize our variable a, which is the initial lower limit, b, which is the initial upper limit, n is the number of interval, h, width of the interval, sum1, sum2, sum3, and integration. Then we have to take the necessary inputs of the variable like a, b, and n. And then we have to calculate h from our inputs, that is h is equal to b minus a by n. Then we have to take the sum1, which will be the value of the function for the lower limit and the upper limit, that is sum1 is equal to fa plus fp. Then this is necessary. We have to calculate yi's for all xi's I is equal to 1 to up to n minus 1 using a for loop. And after this, we have to find the all odd yi's and sum up them into sum2. It have to be kept in mind that we have to find the all odd yi's and sum them and store them into sum2. After that, we have to find the all even yi's and then we have to add them and sum them in sum3. Okay, so now we have sum1, sum2 and sum3. What is sum1? Sum1 is the sum of the first and the last arguments. And what is sum2? Sum2 is the sum of the all odd yi's, and sum3 is sum of all even yi's. So now After having all of these sums, we have the value of the integral, which is nothing but h by 3 into sum 1 plus 4 into sum 2. Why this is 4? This is because sum 2 is the sum of all the odd yi's, and plus 2 into sum 3. Why this is 2? Because sum 3 is the sum of all the even yi's. So this is our formula for integration. So this is all of this algorithm we need to code a Simpson's 130. So let's see a code and how it's work. Here I have here I have written a code in C. So the first of all we have to define the function. So this is our function, which is 1 by 1 plus x square. Previous one as the trapezoidal rule. After that I have to initialize the variable. So I need the variable I, n, a, b, h, x, y's, sum 1, sum 2, sum 3 and integral. Okay, so this is all our variables. And now I have to take inputs for a, b and n. So I have taken input for a and stored this in A. I have taken input for B and stored this in B. I have taken input for N. Here N must be an even number and stored this in A. After that, I have calculated H by using B minus A by N. So I have A, B, N and H. Now I have to calculate the Y values and sum them. So I have initialized sum 3 and sum 2 as 0. Now for I is equal to 1 to I less than n, I have calculated the yi's. Now I have all the yi's, and here I started our conditioning. If I is divided by 2, then yi will be sum up in sum 3. Otherwise, if I is not divided by 2, then yi will be sum up with sum 2. This is all happening in the for loop. So for I is equal to 1, we are entering in the loop and we are calculating x1, which is a plus 1 into h, and for x1 we are calculating y1, which is f of x1. And now if I is divided by 2 and it is true, then the yi will be add up in sum 3. If it is not, then it will be sum up in sum 2. So after that, we are leaving the for loop and again go back to the for loop. For I is equal to next value 2, we are entering here x2 is equal to a plus twice h, y2 is equal to f of x2. If I divided by 2, then it will be sum up with sum 3, otherwise it will be sum up with sum 2 and so on. After completing the for loop, we are exiting the for loop and adding the first value and the last value of y in sum 1. So now I have sum 1, which is the sum of first and last value, sum 2, which is the sum of the all odd values, and sum 3, which is the sum of all even values. Make sure that you are clear up to this point. I have three sum 1, which is the sum of first and the last value, sum 2, which is the sum of all odd values, and sum 3, which is the sum of all even values. Now I am applying my Simpson's 130, which is h by 3 into sum 1, that is sum of first and the last value, plus twice into sum 3, that is twice into sum of the all even values, plus 4 into sum 2, that is 4 into sum of the all odd values. Okay, and then printing our integral value. Let's run this code in C and see what happened. Okay, thank you.